Okay, hi, assalamualaikum and greetings. This is a discussion video for FMS Group 5 for Lab 5. Okay, so looking at the lab sheet, first we have task 1. We have to design a four-way traffic light control system using CX supervisor for SCADA and CX programmer for PLC. And then task 2, we have to design a Apple packaging system uh, using SCADA using CX supervisor and PLC using CX programmer. Okay, so we have did the lab. We did the lab. So this here is the CX supervisor design. So any question?
Okay, for Nazri, I have a question for you. Okay, how do you animate the car moving exactly?
Okay, so to animate the car moving, we actually did animate it. We can change its setting of visibility based on an address. Its visibility can be set visible or invisible according to high or low state of an input or output. For example, a call from CX programmer. So for example, this let's say east side of the traffic, there's a car here. The one that I'm clicking here is for when it is red, but for this one in the middle from the east side is for green. So we can change its visibility from looking at the animation editor and click on visibility. So we can see that the digital expression is red is for the car waiting in front of the traffic light. Okay, so my question is to Eddie, how to display counter number in CX supervisor. Can't seem to find any display for the number.
Enter number because it's not like CX designer. CX supervisor does not have numeral display, so we have to manually make one by using text and assign an integer point editor with counter address where the maximum and minimum count can be set. But actually, we done this lab before using CX designer. Then what makes this different than the previous lab?
Okay, to that question, previously, you guys know that we use CX designer, but now we use CX supervisor for SCADA system. So for SCADA, we should add a SCADA screen where we can oversee the data and the states from a different process at once. So in a compact screen, I would say. Mm.
Okay, that's it for discussion. Next is simulation. Okay, this is the simulation for lab 5, task 1. Four-way traffic light control system. Okay, so on the left side we have the SCADA using CX supervisor, and on the right is PLC using CX programmer. Okay, so looking at the PLC first, we have rungs for activation. We have start, stop, and then the system coil output for controlling all the system to activate the whole traffic light system. And then we also have order reset rung and rungs for each traffic site, which is north, east, south, and then west. Okay, so for each have their own timer for green and yellow. So we have here the green light, and then the green for north, and then yellow for north, and then red for north. So for north, it have timer 6 seconds for green, and then 3 seconds timer for yellow, and 27 seconds timer for red. Only red have a timer for only north have the timer for red, while other do not have timer for red. Instead, have a red light output, but it is only activated when the green or yellow is low. Okay, so let's try running the system. Okay, we press push button, start push button, and it will start. So the system will start, and then the north will lit up green light, yellow, and then red. After north has been reached red, the east will turn green, and so on to south, west, and then back to north. So it's a clockwise cycle. Okay. So 6-second green, yellow for 3 seconds, and then 27 seconds for red. Okay. The whole system, the whole operation can be seen in this SCADA screen here, compacted here. So the system north, east, south, west. So it's like it's a compressed version of this. The cycle will continue until the stop PB is pressed. We can also The cycle will continue until the stop PB is pressed. So when I press stop PB, the operation will stop. When we start again, it will start at the north and cycle through east, south, and west in clockwise. So that's it.
Okay, for task 2, lab 5, and its sequence, we will explain about this. And first of all, the PLC sequence start with a push button, a stop, and a latch. The box conveyor, the apple conveyor, and the counter to count the number of apples, and a differential down for sensor 2, which will be explained later on. So now we can proceed to the SCADA screen. So now it indicates that it is in off state. So we need to turn it on first, and then it will indicate off state. So it's in off state. I will demonstrate again. So if we start the system, it will turn into an on state, indicating that the conveyor is start to run. So once it starts, the conveyor carries the box will operate, and it delivers to the sensor S2 here. So the conveyor will stop after the box passed the sensor S2 due to utilizing the differential down sequence in this function, differential down function, to stop the box after it passes S2. So release, and now the box conveyor has stopped. Now the apple conveyor is start to operate. So once the box is in place, the apple conveyor will operate to drop the apples, and sensor S1 will start to count the numbers of apple that will be dropped. In this case, we set it to 10. So let's trigger it. 9, 8, 7, 6, 5, 4, 3, 2, 1, 10. Okay. Now that's settled, the conveyor will start to continue to operate, and will deliver the completed process to the next process. So the sequence will continue until the stop button is being initiated. So that's all.